Good afternoon, class. Today we'll do section 8.4 and 8.5. Okay? Section 8.4 consists of quadratic functions and their graphs. Section 8.5 consists of quadratic and nonlinear inequalities. Let's start with section 8.4. Okay? Section 8.4. 8.4. These, like we said, are quadratic functions and their graphs. Okay, let me get you started with the basic quadratic function. Okay? The basic quadratic function is this one. F of x equals to x squared. This is the basic quadratic function. Basic quadratic function. We can graph this function. Yes, we can. Okay? We can graph the function. I'm going to make a table. So here's x, and here's f of x. X is 0. 0 squared is 0. X is 1. 1 squared is 1. X is 2. 2 squared is 4. X is 3. 3 squared is 9. X is negative 1. Negative 1 squared is 1. Negative 2 for x. 4 for y. Negative 3 for x. 9 for y because you squared negative 3. Okay? When you graph, I want you to see the behavior. Okay? So here's x and y. Okay? I want you to understand the behavior of this function. Look, the vertex, in this case, is going to be 0, 0. X equals 0, y is 0. Look at the behavior. When x is 1, y is 1. So x is 1, up 1. Okay? Behavior from the vertex. 1 to the right, 1 up. That's the behavior of the basic quadratic. X is negative 1, y is 1. So behavior from the vertex, 1 to the left, 1 up. That's the behavior of the basic parabola. 2 to the right, 4 up. From the vertex, 1, 2 to the right, how many up? 1, 2, 3, 4. 4 up. 2 to the left, how many up? 4 up. See? That's the behavior of the basic parabola. 3 to the right, how many up? 9. 5, 6, 7, 8, 9. Okay? 9 up. 3 to the left. 9 up. So this is the behavior of the basic parabola. So behold the basic parabola. That's what it looks like. Okay? Basic parabola. I want you to understand the behavior. Basic parabola. 1 to the right, 1 up. 1 to the left, 1 up. So if someone asks you, how does the basic parabola behave? You're gonna say go to the vertex, and from the vertex, move once to your right, one up. From the vertex, once to your left, one up. Behavior of the basic parabola from the vertex, okay? From the vertex, twice to the right, 4 up. Twice to the left, 4 up. From the vertex. From the vertex, stand on the vertex, 3 times to your right, 9 up. 3 times to your left, 9 up. That's the behavior of the basic parabola. Okay? All right. Now we can mess with the basic parabola. Yes, we can. We can mess with the basic parabola. Okay? Watch this. Let me call this g of x. And I'm going to do this one in red. G of x. G of x equals to 2 times x squared. So, what's going to be the behavior of this parabola? Well, this is the basic parabola, x squared multiplied times 2. Okay? So this basic parabola, actually this parabola, this is the basic one. This parabola, watch the behavior. Okay? Watch this. This parabola is the basic parabola, x squared times 2. Don't forget that. So, to graph that, you say once to your right. If it was the basic parabola, you would say 1 up. But because this is multiplied times 2, you will say once to your right and take the basic parabola, that 1, and multiply times 2. So now this is going to be from the vertex, once to your right, and take that 1, multiply times 2. What's 1 times 2? 2. The vertex is the same. Once to your left, you're going to take the basic parabola, that 1, multiply times 2. What's 1 times 2? Because, see, this is the basic parabola, multiply times 2. So take that 1, multiply 1. What's 1 times that 2? 1 times 2 is 2. Mm-hmm. For this parabola, twice to your right. Before it was 4. Now you take that 4 and multiply times 2. What's 4 times 2? 8. So twice to your right, 8 up. 1, 2, 3, 4, 5, 6, 7, 8. Twice to your left, how many up? 8 up. 4 times that 2. 8 up. Okay? So it looks like this. Okay. See? So these two just stretched the basic parabola, the dark one, stretched vertically by a multiple of 2. Okay? That's what that 2 did. Okay? Let's do another one. Let's do this one, look. Let me call this one h of x. Uh-oh, no blue. I need blue, but I don't have it, so I gotta do it in black. call this h of x equals to 2/3 x squared. Okay? So this is the basic parabola, okay, multiplied by 2/3. Okay? Don't forget, the basic parabola is the black graph, the original. That's the basic parabola. Let me show you how to graph this one. Okay? So just think of the basic parabola multiplied times 2/3. Okay, very good. So to graph this, one's to your right, and then if it was the basic parabola, one up. Now you're going to take that 1 and multiply times 2/3. What's 1 times 2/3? 1 times 2/3 is what? 2/3 right there. 1's to your left. 1 times 2/3, 2/3 right there. So this is it's like you're pushing on the parabola down. Do it again. Twice to your right. Twice to your right. The basic parabola is 4 up. Now you're going to take that 4 and multiply times 2/3. What's 4 times 2/3? That equals to 8/3, which equals to 2 and 2/3. Okay? So watch. Twice to your right. Before it was 4. Now you take that 4 and multiply times 2/3. 4 times 2/3 is 8/3. 8/3 is 2 and 2/3. So 1, 2, and I'm going to say 2/3 is right around there. Twice to left, 2 and 2/3, right around there. 3 times to your right. 3 times to your right. Before it was what? This one? 9 up. Now you take that 9 and multiply times 2/3. What is 9 times 2/3? Okay, don't forget. 3 times to the right. In the basic parabola, it was 9. Now you're going to take that 9 and you're going to multiply times 2/3. What is 9 times 2/3? 9 times 2 is 18. 18 divided by 3 equals 6. So 3 times to your right, 6 up. 1, 2, 3, 4, 5, 6. And 3 times to your left, 6 up. So we're getting this parabola. So it seems to me that when you multiply this, the basic parabola, by a number that's less than 1, it's a vertical compression. It's like you push it down. You make it wider. Okay? So when this is less than 1, you make it wider. The parabola becomes wider than the original parabola. Now, if you don't believe me, watch, let's make a table. Make a table. Watch this, I'm gonna make a table. I'm gonna plug in 1, and we're gonna get 2/3. I'm gonna plug in -1, and we're gonna get 2/3. I'm gonna plug in 2, and we're gonna get, what do we say? 2 and 2/3. Okay, watch this. Make a table. X and h of x. Plug in 0, you get the same thing, because 0 squared times 2/3 is 0. Plug in 1. 1 squared is 1 times 2/3 is 2/3. Plug in -1. -1 squared is 1 times 2/3 is 2/3. Plug in 2. Okay. This is going to be 2 squared, which is 4, correct? 4 times 2/3. What's 4 times 2? 8/3. Plug in -2, and you're going to get -2 squared is 4. 4 times 2/3 is 8/3. Same as before. Plug in 3. 3 squared is 9. 9 times 2 is 18. 18 divided by 3 is 6. You see? Plug in 3 and you get 6. Plug in -3 and you also get 6 again. So we got it right. We got it right. Okay? All right. If this is ever negative, the parabola opens down. Okay. Might as well just give you one, okay? So here we go. Here's another parabola. I'm going to call this one L of x. L of x equals to negative, what should we say? Negative, should we say -1/2? -1/2 x squared. Okay, so this parabola is going to open down. If we multiply by half, opening down, this negative means it's going to open down, multiply by half, okay? It's -1/2, okay? But I'm saying it opens down. I wish I had different color, but I don't. Watch what's going to happen. If x is 0, this is 0. The vertex, same vertex. Vertex. If x is 1, the basic parabola, if x is 1, don't forget, the middle one is the basic parabola. If x is 1, before it was in the basic parabola, this one, in the basic parabola, it is, if x is 1, it is from the vertex 1 to the right, 1 up, right there. Now you take that 1 and multiply by -1/2. What's 1 times -1/2? -1/2. If x is, okay, let me say it again. In the basic parabola, this one, 1's to your left, 1 up. Now you take that 1, multiply by -1/2 to graph this one. And what do you get? -1/2. Do it again. The basic parabola. We can always guide ourselves with the basic parabola. From the basic parabola, twice to the right, 4 up. Now you take that 4, multiply by negative half to graph this one. What's 4 times negative half? 4. Whoa, running out of markers. What's 4 times negative half? That equals, what's 4 times half is 2. Negative half is negative 2. So twice to the right, 4 up, take that 4, multiply times negative half, you get negative 2. Hey, right there. Twice to the left, 4 up, 4 times negative 2, 4 times negative half is negative 2. You see? We're graphing this one using that one. Do it again. Do it one more time. This one. 3 times to the right. 9 up. Right there, the middle one. 9 up. Now you take that 9 and multiply by this negative half, which is negative 9 halves, which is what? Negative 4 and a half. So for this one, when x is 3, you get negative 4 and a half. Negative 3, negative 4, negative 5, right there in the middle. X is 3 in the middle, negative 4 and a half right around there. X is 3, x is negative 3, the same thing, right in the middle, right around there. It became wider and it opens down. Okay? Pull this one a little bit more this way. 1, 2, 3, 4 and a half right around the middle, right there. Okay. And down, around the middle. Just try my best. Whoa. I don't know what happened here, but you know what I'm saying. There you go. Okay? That would be this one. All right. Excellent. Okay. So now we understand what this constant stands for. This is the leading coefficient in a parabola. The leading coefficient tells us whether it's been stretched this way or compressed, whether it opens down if it's negative, okay, also stretched down, okay. So this one in reality is wider. So it's kind of being compressed, I don't know, maybe this way, okay? So it was made wider. Okay. All right, so there you go. I graphed 4 parabolas, and they were graphed based on the basic parabola f of x equals x squared. Okay, very good. All right, let me erase this because I need the room. So don't forget the behavior of the basic parabola. Let me ask you again, what is the behavior of the basic parabola? Here's the behavior. Go to the vertex, go to the vertex. One's to your right, how many up? 1 up. From the vertex, one's to your left, how many up? 1 up. Behavior of the basic parabola. Go to the vertex again. Go to the vertex. Twice to your right. How many up? 4. From the vertex, twice to your left. How many up? 4. Don't forget, that's the behavior of the basic parabola. Once you understand that behavior, then you understand what this coefficient is doing to the basic parabola. Okay? All right, very good. Now, okay. So look at this. Look at this parabola. G of x equals 2 times x minus 3 quantity squared. Let me make it easy, okay? Let me just make it easier. Get rid of this 2 and do this plus 4. This is a parabola. This is a basic parabola. Yes. Don't forget, it's a parabola. Remember, it's the basic parabola, but this one has been shifted 3 times to the right. 4 up. Do you remember the behavior of the basic parabola? Do you remember the behavior of the basic parabola? Let me show you the behavior of the basic parabola. You should already know it. Here we go, look. The behavior of the basic parabola is what? Behavior, basic parabola. The vertex is right there at 0, 0. Behavior, one's to the right, 1 up, one's to the left, 1 up. Twice to the right, how many up? Basic parabola, 4 up. 2, 3, 4 up. Twice to the left, 4 up. 3 times to the right, how many up? 9. I don't have room, okay? So therefore, this is the behavior of the basic parabola. 9 up. 3 times to the left, 9 up. Okay. Now, what is this gonna do to the basic parabola? You see the coefficient there? This is an invisible 1. So this invisible 1 means that it's not going to compress it, it's not going to stretch it, it's not going to do that. It's going to be the same behavior with a new vertex. What's the vertex? This parabola has vertex of what? 3, 4. Take the opposite of this and do not take the opposite of this. So this parabola takes the basic parabola. The vertex is going to move 3 to the right, 4 up. 1, 2, 3, 4. And this is the new vertex for g of x. This is the new vertex for g of x. Because g of x, look at this leading coefficient, 1. The behavior is the same as the basic parabola. Okay? Watch this. From the vertex, what's the behavior of the basic parabola? You tell me. What's the behavior of the basic parabola? Go to the vertex. 1 right, 1 up. 1 to your right, 1 up. 1 to your left, 1 up. Twice to your right, 4 up. That's the behavior of the basic parabola. This one behaves the same way because the leading coefficient is 1. Okay? So watch this. From the new vertex, watch this. 1 to your right, 1 up. from this vertex, one's to your left, one up. You see? From this vertex, twice to your right, how many up? 4 up. 1, 2, 3, 4 up. 4 up, right around there, okay? Twice to your left, how many up? 4 up. Approximately there. So we're gonna get this one. There we go. That's the behavior of x minus 3 quantity squared plus 4. Note, it was not vertically stretched nor compressed. It was not reflected. No, it wasn't, because this coefficient is positive. It opens up. And it is 1. Remember, f of x equals the base of parabola square. This is also 1 there. Same as this 1. Okay. Very good. Excelente. Okay, I'm sorry I made a mess here. Okay? All right. So we're getting the point here. Let's do another one. Let me erase this one. Well, yeah, I'm going to erase this one because it became a mess. Okay, let's do another one, so you understand more. Okay? So we just did this one. Let's do another one so that we can understand. Okay? Here's another one. Look at this other one. H of x. Let me do this one in red. How's that? H of x equals to -2 times x plus 1 quantity square minus 2. There you go. So what is this going to do? The basic parabola shifted 1 unit to the left, 2 down, and opens downward by a multiple of 2. So it's like being stretched this way. Okay? So let's find the vertex. Vertex is what? Where? Where's the vertex? -1, -2. Okay, let's also take the axis of symmetry. Let's worry about the vertex for now. We'll talk about the other one later. Okay, so remember the vertex, the opposite of this, not the opposite of this. The opposite of this is for the x value, not the opposite is for the y value. So the new vertex, so you see this basic, this is f of x, but I'm going to take its vertex, I'm going to move it once to the left and 2 down. And that's our new vertex. Now, to graph this, let's not forget the behavior of the basic parabola. What's the behavior of the basic parabola? Basic parabola, go to this vertex. Once to your left, one up. Once to your right, one up. Twice to your left, four up. That's the behavior of the basic parabola. How about this one? Okay. From the vertex, once to your right, don't forget, from the vertex of the basic, once to your right, one up. How about this one? Once to your right, take that one, multiply by -2. Take that one by multiplying by -2. So what's 1 times -2? -2. So from the vertex, once to your right, 2 down. Right there. Once to your left, 2 down. Yes. From the vertex, twice to your right. 1, 2, twice to your right. Before it was 4 up. Take that 4 multiplied by -2. So twice to your right. What's 4 times that -2? -8 down. 1, 2, 3, 4, 5, 6, 7, 8. So twice to your right, 8 down. Twice to your left, 8 down. There you go. Beautiful. Okay, so we graph this based on the behavior of the basic parabola. If you don't believe me, watch this. If we plug in 0, we're gonna get -4 there. Plug in 0. I'm not kidding you. Watch this. X and h of x. Plug in 0. To begin with, when you plug in 0, I bet you're gonna get, when you plug in 0, I bet you're gonna get x equals 0. You better get -4. Otherwise, I made a mistake. Plug in 0. There. -2 times 0 plus 1, quantity squared, -2. This is 1. What's 1 squared? 1. What's 1 times -2? -2. What's -2 minus 2? -4. Hey, x is 0, we get -4 right there. I bet you if we plug in 1, we're gonna get -8. Yeah, let's plug in 1. Plug in 1. This works. So that's -2 times, plug in 1, plus 1. I just plug in 1 there. Quantity squared, -2. Let's see what we get. We better get -8, otherwise we made a mistake. What's 1 plus 1? 2. What's 2 squared? 4. What's 4 times -2? Whoa. Let me see. Oh, you get -10. Watch this. You plug in 1, you better get -10. I was counting incorrectly. Why? Because watch this. 1, 2, 3, 4, 5, 6, 7, 8, 9. It should be 10, okay? So here's what happened. Let me just show you what happened, okay? 2 to the right, there, it should be 4 times -2. What's 4 times negative 2? 8, right? Down. So 1, 2, 3, 4, 5, 6, 7, one more, 8. I'm just off a little bit. Okay? So there we go. Should be right there. I just didn't go all the way down. There you go. And the same thing there. Okay, this one is this one correct? Let me just do this. Okay. Right. Okay. So there you go. I know my graph is not perfect, but you guys understand what I'm saying. All right. So you plug in 1. This works, okay? What I'm doing works. When you plug in 1 here, plug in 1, plug it in, that's 2, 2 squared is 4, 4 times negative 2 is negative 8, minus 2 is negative 10, so this is negative 10, negative 10, watch this, plug in 1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right there. It works. Okay. So to graph this parabola, you go to the vertex, and twice to your right. Before it was 4 up. Now you take that 4 and you multiply it by negative 2. And what's 4 times negative 2? That's negative 8. So you go from this, you go 8 down, right there. Twice to your left, 8 down, right there. I just had my points. I should have went down a little bit further. Okay, there you go. So this works. This works. If you don't believe me, you plug in, let me see. If you plug in negative 1, you better get negative 2. Plug it in. If you plug in, let me see, x equals negative 1, negative 2. If you plug in negative 3, plug in negative 3, so you're going to get 10 down. 10 down. Okay. All right, so because negative 3 plus 2, what's negative 3 plus, negative 3 plus 1. What's negative 3 plus 1? That's negative 2. Negative 2 squared, that's 4. What's 4 times negative 2? Negative 8. What's negative 8 minus 2? Negative 10. One, two, three, negative 10. But that, remember, vertex, twice to the left, before, base of parabola is 4. Remember? Twice in a base of parabola. Let me say it like this. In a base of parabola, twice to your left, twice to your left, twice to your left, 4 up. Take that 4, multiply by negative 2. So what's 4 times negative 2? Negative 8. So in this parabola, twice to your left, 8 down. From the vertex, twice to your left, 8 down, right there. Twice to your right, 8 down. How about 3 times to your left? Come on, tell me. 3 times to your left. Well, from the vertex, 3 times to the left, go to the vertex. 3 times to your left. In the base of parabola, it was 9 up. Take that 9, multiply by negative 2. What's 9 times negative 2? Negative 18. So from the vertex, 3 times to your left, 18 down. Okay. And what's 18 plus this 2? 20. So therefore, 3 times 1, 2, 1, 2, 3, 4. 3 times to your left, is x equals to -4. Look, that's x equals -4. I bet you, without even looking, it's gonna be, what do we say, -20? Plug it in, plug it in. -4. -4 plus 1. What's -4 plus 1? -3. What's -3 squared? 9. What's 9 times -2? -18. What's -18 plus -2? -20. Very good. I'm showing you how to graph parabolas now. Okay. Very good. Excellent. I think we are ready now to take any parabola in any form and be able to graph it. Okay? Watch this. All right. So, okay, here's this parabola. Unfortunately, not all parabolas are given in this form. Oh, by the way, I forgot. Okay, so let me erase this. I forgot to tell you. Axis of symmetry is x equals 2. Just say x equals 2, and wherever this is for the vertex, -1. What's the axis of symmetry here? Axis of symmetry is x equals to -3. What does the axis of symmetry does? The axis of symmetry cuts the parabola exactly in half. That's the axis of symmetry. It cuts it in half. That's why sometimes I call the axis of symmetry a blade. Like a blade, you know, take a blade, you cut it with a blade. Well, if you cut this parabola through the axis of symmetry, you're cutting the parabola exactly in half. There you go. Cut this one in half. If you cut this one in half, it's gonna be at x equals to 3. Right there. I said -3 earlier, didn't I? But it's 3. Right here. This one. Okay. Very good. Okay. What was I gonna say? What I was gonna say earlier was that not all parabolas are given in this form. Unfortunately, if they are given in this form, it's easier to graph. But watch, I can write this parabola in a different form. Okay, watch this. Watch. You see this -2? Who knows what x plus 1 squared is? What's x plus 1 squared? This square is what? X squared plus 2x plus 1 minus 2. You take the time and you multiply x plus 1 times x plus 1. You FOIL, and you're going to get this. Watch. Distribute this negative. This is -2x squared minus 4x minus 2 minus 2 minus 4. Look at that. 2 So this parabola is this one. This trinomial. But if you have it in this trinomial, you don't see the vertex. Although, you can still get the vertex from here. What is the vertex? What's the vertex? What's the vertex, guys? The vertex? -1, comma, -2. If you're given the parabola in this form, this is h of x, okay, guys? If you're given the parabola in this form, you can still get the vertex by using this formula. The x-coordinate of the vertex is -b over twice a. The x-coordinate of the vertex, that's going to give you this one. We better get -1, otherwise we made a mistake. -b, -4 over twice a. What is a? -2 equals to, what's negative times a negative? Positive. What's 2 times -2? -4, which equals to -1. That -1 is right there. So you can still find the vertex if the parabola is given as a trinomial. You can. We're not done. The y-coordinate of the vertex is the function when you plug in the x-coordinate of the vertex. Of course, in this form, okay? So take -2 times, what's -1? X is -1, okay? Let me say it like this. Let me say it like this instead. This equals to f of -1. So you guys understand what I'm doing. Because I found out that this is -1, I'm gonna take that -1, I'm gonna plug it into the function, okay? Once I plug it into the function, I get my y value of the vertex. Okay. And what is this? We'll take that -1. Remember, I am referring to this one. If we have it in this form, it's easy to get the vertex. But not if you have it in this form. You have to go through these formulas. Okay, so let's get the y-coordinate of the vertex. We better get -2. When you plug in this -1, what's -1 squared? 1. What's 1 times -2? -2. What's -1 times -4? +4. -4. This +4 cancels this -4. The answer is -2. Exactly this. So here's another way to find the vertex. You use these formulas if your parabola is given as a quadratic trinomial. If it's given in this form, well, that's easy. -1, -2 is the vertex. Once you have, if it's given in this form, use this formula to find the vertex. Okay? All right. Well, here's my question. If the parabola is given in this form, how can you get it back to look like this? I'm going to show you how. Okay? If the parabola is given in this form, look, h of x equals to -2x squared minus 4x minus 4. How can we get this one in that form? How can we get this one in this form? Look, f of x equals 2a times x minus h quantity squared plus k. We want this parabola in this form, which is essentially this form, this one. How can we do it? We complete the square, okay? That's what we do. Complete the square. Complete the square. Remember, in completing the square, this leading coefficient must be 1. So that's what I'm going to do. I'm going to complete the square by making this leading coefficient 1. How can I make this 1? Divide everything by -2. Okay. Divide this by -2. Divide this by -2. Divide this by -2. Push this aside. You want to make room, but divide it by -2. Divide this by -2. Divide this by -2. And make room. Okay, so I divide this by -2, divide this by -2, divide this by -2, divide this by -2. And now, I'm going to take half of this. What's half of 2? And I'm going to square it. What's half of 2? 1. This is 1. Square. And if you go back and you read and you see my other video, highlight this. This one, highlight it because you're going to use it. Okay. So what's 1 squared? 1. So you're going to add 1. And subtract 1. Yep. Look. If you add 1, you have to subtract 1, because if you don't subtract 1, then you're not working with the original problem. You messed it up. So you have to add 1 and then subtract the same thing. You always have to do that. Whatever you add, you must also subtract. But you need to make the room first, okay? You make the room, take half of this, whatever this is, half of it, square it, okay? Square it. Here you go. If you want to highlight, you can highlight it. Highlight the inside before being squared. And then you get 1. You add this 1 and you subtract 1. And watch what happened. Okay, I need the room, okay? Do it. Let me go here. Watch what happened. Yeah, I need the room. Let me go here. I'm gonna go right there. Watch this. H of x divided by -2. Who knows how to factor this? Isn't this x, and then take what's inside, whatever's inside, plus 1. I see a plus 1 there. I just did This was -1. Note, this one, and this one became the binomial squared. This one and that one, put them together. What's -1 plus 2? Plus 1. And now, get rid of that one. Multiply everything by what? By -2. Yes. Multiply this by -2. Multiply. Let me make some room here. Multiply this by -2. And multiply this by -2. The negatives to cancel. H of x equals to -2 times x plus 1 quantity squared. What's 1 times -2? -2. And you're back to this. So you went from here to there by completing the square. Look, nice. We love it. Hey, this is beautiful. I don't care what anybody thinks. This is beautiful. Okay. Awesome. Want to do another one? Let's do another one. Okay. Let's do another one. Okay. All right. So what are we doing? If I'm given the quadratic trinomial, a quadratic function in this form, I can express it in this form by completing the square. Okay. Let's do another one. Watch this one. Let us do this one. Look. Oh, there's a good one right there. There's a good one. Okay, so if we're given this, if we are told f of x equals to 3x squared minus 12x, 3x squared minus 12x, and then what else? Plus 8. And they tell us, express this function in that form. Okay? And you're going to say to yourself, yes, we can. We can express this function in that form. Okay? Now, if they tell you find the vertex, you can find the vertex right away from this trinomial using these formulas. So the vertex, not a problem, right away. But if they tell you express this function in this form, you say to yourself, oh, that's fun. That's what you need to say to yourself. That's fun. You need to practice, okay? All right, so how do we express it in this form? Complete the square. Complete the square. And how do we complete the square? Make this 1. Divide everything by 3. Push this aside, make room. Let's do that. Divide this by 3. Divide this by 3. Divide this by 3. Divide this by 3, but push it aside. You see? Now, take half of this. Square that. Before you square it, Simplify this. What's half times -4? Before you square it, highlight it because you're going to use this, guys. You're going to use this -2. You are going to use this -2, so you better highlight it so you don't forget. You're going to use this -2. By the way, what's -2 squared? 4. So you're going to add 4 and you're going to subtract 4. You add 4 and you subtract 4. Yeah. Okay. Beautiful. This is beautiful. Watch this. Who knows how to fact? Okay, let me rewrite it. F of x divided by this number 3 equals 2. We can factor this now. This is going to be a binomial to the second power. 1, 2, these first 3 terms. That's a binomial to the second power. What binomial? It's going to be an x and then whatever you highlight inside goes there. So what did I highlight? I highlighted -2, so -2 goes here. If you want to, you can combine those two if you want to. If you want to, you can combine them. Let's combine them because most likely you're going to have to. Okay? But you don't have to. Okay. All right, I'm going to combine it anyways for you guys. Another way you, watch. Keep it. Okay. Usually I would combine them, okay? But let me show you another trick. Now, I want to get rid of this 3 here. So I multiply everything by 3. Everything by 3, guys. Multiply this by 3. Multiply this by 3. Multiply this by 3. And multiply this by 3. That's beautiful. The 3's cancel. Get f of x. This is 3. X minus 2, quantity squared, minus 12. The 3's cancel. Plus 8. F of x equals 2. 3 times x minus 2, quantity squared. What's -12 plus 8? -4. Okay, so you didn't have to combine those two. If you did, it's fine. You still get the same answer, okay? And now you can graph this. This is a parabola. Shift it 2 units to your right. 4 down. That's the vertex. Vertex is 2, comma, -4. Axis of symmetry, axis of symmetry is x equals 2. And you can graph it, okay? All right, this was long. This was section 8.4. Unfortunately, I also have to do section 8.5 because I want to finish this chapter, okay? So, this is gone, I'm sorry, gotta go. So let's do section 8.5. In section 8.5, section 8.5, 8.5 is quadratic inequalities and nonlinear inequalities. Okay, 8.5. 8.5 quadratic inequalities. And nonlinear inequalities. I'll just say it and you guys write it, okay? That's 8.5. Let's do quadratic inequalities first. Okay? Suppose we're told to solve this. Solve x squared plus x less than 12. Solve. Okay. This is a quadratic inequality. This is an inequality symbol. The first thing you need to do for this one is make 0 on one side. That's the first step. I'm gonna make 0 right there. Bring this 12 to the left. Okay. So we're gonna make 0, the first step, make 0 on one side. Okay, no problem. X squared plus x minus 12 less than 0. So really what we're asking here is, remember, what is this? You guys recognize this? This is a parabola. That's a parabola. And we're asking where this parabola opens up. And we're asking where is the parabola below the x-axis? Less than 0. That's the question. Okay. Without even graphing, because you know how to graph the parabola now, and you need to understand the question is where's the parabola less than 0? Or where is the parabola below the x-axis? Without even graphing, I'm going to show you how to solve this. Okay? So once you make one side equal to 0, what you need to do is you need to find what I call boundary values. How do you find boundary values? This is just to find boundary values. You change this to equal. No, this is not the original problem. No, the original problem is less than. Okay, but I just want to find the boundary values. And then you solve this. You solve whatever this is. Okay. Solve. X times x, 3 times 4, plus and minus. Solve. Solve. X equals 3 from this one, or x equals -4. So these are the boundary values. Yeah. You go to the number line. You go to the number line and you graph the boundary values. These are the boundary values. So here's my number line. And I'm gonna go to -4, -4, circle -4. And I'm gonna go to 3, go to 3, circle 3, okay? I'm trying to solve this. Okay, so these two factors gave us two boundary values. And two boundary values divides. Yes. Two boundary values divides the number line into how many regions? 3. From -4 to my left, the first region. From -4 to 3, the second region. From 3 to my right, the third region. Well, here's what I'm gonna do, okay? Now that I found the boundary values, I'm going to check each region, okay? I'm gonna check each region. If that region makes this one true, then I'm gonna shade. Okay? Okay, so you got this, right? We found the boundary values, no problem. Now, don't forget, this one here is here. Okay, now I'm gonna go back to the original problem, okay? So we found the boundary values. You know how to do that, right? Okay. Now we're gonna check. And it's easier to check in the inequality that's in factor form. Okay. X, 3, 4, right? Plus, minus. Okay. I'm gonna check each region, this region. I'm gonna plug in a value from here, there. If it makes it true, I'm gonna shade. If it makes it false, I'm not gonna shade. Okay. Try the first one. What value from this region should I plug in? What's to the left of -4? -5. I'm gonna plug in -5. X equals -5. Plug it in. What's -5 minus 3? -8. What's -8 plus 4? -4. Is this true or false? A negative times a negative is positive. Is a positive less than 0? That's false. This is false. So you don't shade that region. You do not shade that region. Okay, go there. What's the easiest value for this region? X equals 0. What's 0 minus 3? That's -3. Basically, all you need is the sign, okay? -3. -3. You can just say negative. If you want to say -3, it's fine with me, but you can just also say negative. What's 0 plus 4? That's positive 4. You could say positive. What's the negative times a positive? Negative. Is a negative less than 0? True. So I'm going to shade this region. Yeah. This region is the solution to this one. Okay, let me check the last one. Although once you get practice, you realize that for this problem, you're done because it's a parabola. It's a parabola. Okay. What they're saying is that the parabola is less than 0 in this interval. But if you don't understand, no problem. Let's check the last region. What should I plug in for the last region, for this region? X equals 4. What's 4 minus 3? 1. You say 1, but you can also just say positive 1, okay? You can say positive. What's 4 plus 4? 8. You can say 8, or you can just say positive 8, or just positive. Is a positive times a positive, is that less than 0? No, this is false. Now, you see this inequality? It does not have equal. Because it does not have equal, the boundary values stay open. They are not shaded. If it did have equal, you would shade them. Okay? And so we found the solution to this problem. Yes, we did. What is the solution? Solution. Where should I write it? So, solution to this problem. So I'm going to write it here. Solution. It's going to be from -4 all the way up to 3, excluding with parentheses, excluding with parentheses. That's the solution. Yep, we got it. Okay, want to do another one? Sure, let's do another one. Let's do another one. Okay. But let's do another one. Okay, let's do this one. Solve. Solve. Solve, for example. Solve this one. X squared, that's an x squared, okay? Minus 8x. They say less than or equal to, I'm going to say greater than or equal to -15. Okay? What's the first step? Set one side equal to 0. X squared minus 8x plus 15 greater than or equal to 0. Now, find the boundary values. The boundary values. You can just factor this and you'll be able to see the boundary values. Watch this. Factor. X times x, 3 times 5, negative and negative. So you tell me, what are the boundary values? X equals 3. Because to find the boundary value, you set this part. X minus 3 times x minus 5 equals 0. So x equals 3 or x equals 5. Those are the boundary values. You could just see it from here. You don't have to do all of this. Okay. 3 and 5 are the boundary values. So let's go to the boundary values. 3, 5, circle, And then now we're going to check each region. Okay? What should I check from this region? From this region, x equals to what? 0. From this region, x equals to what? 4. From this region, x equals to what? 6. But since this is a parabola, you're going to realize that most likely it's going to be the middle region. Let's see. Let's check. X equals 0. 0 minus 3. You could say negative 3, but you just need the sign, negative. 0 minus 5. Negative. Is that it says greater than? Is that true or false? A negative times a negative. Is that greater than or equal to 0? Yes. Shade. Try 4. Try x equals 4. 4 minus 3. What's 4 minus 3? 1. Do you need the number? No. You say this is positive 1. Positive. 4 minus 5. Negative or positive? Negative. It's a positive times a negative greater than 0. What's a positive times a negative? Negative. Is a negative greater than 0? False. You don't shade. Try this one. Try 6. 6 minus 3. That's 3. It's positive 3. You could just say 3. Because it's positive. Positive. 6 minus 5. Positive or negative? Positive. Is a positive times a positive greater than 0? The answer is yes. Okay. Oh, what about the boundary value 3? Well, I see the equal sign, I better shade it. And 5 is also shaded. That's the solution. In integral notation, the solution is what? Solution from negative infinity all the way up to 3, including, excluding, or from 5, including, all the way up to positive infinity, excluding, because you never get there. And that's the solution, good people. We're almost done, okay, because I'm tired too. I'm very tired right now. Okay. So, erase. Erase. Now, do this one look? Two over x minus 1 greater than or equal to 3. Okay? This is a rational inequality. Solve the rational inequality. Okay, very good. Okay. Warning, you do not want to multiply both sides by the LCD, by the least common denominator. Do not. Do not multiply both sides by LCD. Don't do it. If you do that, you may get into a mess. You may get some of the answers, but not all of them. So what do you do instead? Instead, make 0 on one side. Okay, we can do that. Make your own. I'm bringing this to my left. Yes. Do not multiply both sides by the LCD. So here we have 2 over x minus 1 minus 3 greater than or equal to 0. Yeah! The next step is to combine. Yes, combine this fraction and the 3. Combine. And how do you combine? Multiply this top and bottom by what? By x minus 1. So this is going to be 2 over x minus 1 minus 3, and multiply this top and bottom, x minus 1 divided by x minus 1. I'm just trying to combine the fractions, okay? And that's greater than or equal to 0. Note, I did not multiply both sides by the LCD. I didn't do that. I'm trying to combine those two. Now, good class, distribute the negative into this binomial and then combine. But first, let's distribute the negative first. So this is 2, and then negative 3 times x is negative 3x, and negative 3 times negative 1 is plus 3, all over x minus 1 greater than or equal to 0. And last but not least, that's negative 3, negative 3x, and 2 plus 3 is 5, plus 5 over x minus 1 greater than or equal to 0. Yes. Now that we combine, we're going to find the boundary values. Boundary values. Okay, so we have boundary values coming from the numerator, and we have boundary values coming from the denominator. And so the numerator, I'm going to write numerator here, and denominator here. So the boundary value comes from the numerator. Set the numerator equal to 0. So this is negative 3x plus 5 equals 0. The boundary value is coming from the denominator. Set the denominator equal to 0. X minus 1 equals to 0. Solve this for x. Bring this to the right. This becomes negative. A negative divided by a negative is positive. So therefore, this is x equals to 5/3. And this is x equals to 1. And those are the boundary values. We got the boundary values. Go to the number line and locate your boundary values. So this is 1 and 2/3, and that's just 1. So this one goes first. That's 1, circle 1, and this is 5/3, 5/3. Okay? And so now we're gonna pick a value from each region. So from this region right here, I'm gonna pick, from this region, I'm gonna pick x equals 0. From this region. What can I pick from this region, guys? Shall I pick x equals to 4/3? Yeah, 4/3, and you see why. I want to pick something with a 3 in it that's here. I want to pick something with a 3 in the denominator that's in this region. So I'm going to say x equals to 4/3. It's less than that. Greater than this. Yeah. And so here I'm going to say x equals to what? Tell me. 2. Okay. Very good. I'm going to plug in 0 there. What's negative 3 times 0? 0. Plus 5. That's 5. You say positive 5. If you want to say positive 5, you can. All you need is positive. If you want to say positive 5, you can, okay? Positive 5, like this. You can. Plug a 0 there. What's 0 minus 1? That's negative 1. You could just say negative, but if you want to say, you could just say negative. But if you want to say negative 1, you can. Greater than, that's a positive 5. There's parentheses, greater than or equal to 0. It's a positive divided by a negative. What's a positive divided by a negative? That's negative. Is a negative greater than or equal to 0? Is a negative greater than 0? The answer is no. So this stays unshaded. Go to the next one. Try this one. Plug it in there and there. Okay? Plug it in. So watch what happens. The top. Negative 3. And I'm going to plug in a 4/3 plus 5 divided by 4/3 minus 1 greater than or equal to 0. The 3's cancel. These 3 cancel the 3. And so what do we get? What we get here is negative 4. We get negative 4 plus 5. And you see this? What's 4/3 minus 1? What? This is 1 and 1/3. What's 1 and 1/3 minus 1? Isn't that a third? That's a third. That's positive. And the top is positive. So this is a third. That's 1 over a third. You don't have to do the division, guys. You don't have to multiply the verse. No. Just say a positive 1, a positive divided by a positive. Is that greater than or equal to 0? That's what you have to ask. The answer is yes. Shade. Try 2. Try it in there. What's negative 6 times 2? I'm sorry. Negative 3 times 2, that's negative 6. Negative 6 plus 5. What's negative 6 plus 5? A negative 1. That's a negative. Divided by. What's 2 minus 1? That's a positive. is a negative divided by positive. Is that greater than 0? No. Good. So we got the region. Now, what about the boundary values? Okay. Well, let's see. The boundary values is 5/3 shaded. Well, you say, okay, wait a minute. It has equal. Okay. 5/3 is shaded. Yeah, 5/3 is shaded. You're saying, okay, I agree. Is 1 shaded? No. 1 is not shaded. Why not? Why not? Because this 1 comes from here, which is in the denominator. Okay? In other words, this 1 makes this denominator, this denominator 0. Can you divide it by 0? No. No. Whenever a number makes denominator 0, that's undefined. So therefore, when it comes to rational inequalities, if it has equal sign, if it does not have equal sign, they're open. But if it has equal sign, any boundary value that comes from the denominator is always open. So this stays open. Open. What's the solution? Solution. From 1 all the way up to 5/3, including 5/3, so it's a bracket, excluding 1 because it's open, parentheses. That's the solution. Okay. All right, very good class. This finishes chapter 8. Okay? This finished chapter 8. Thank you very much, good class, and I'll see you soon.